Hey there guys, and welcome back. So, it is time to finish this project. At least get the design finished. One of those things wasted, well, I shouldn't say wasted, but we had a segue on an episode, so one of those things. It feels like this project should already be over because it's so simple, but put us back a little bit. So, this is my rods for the top part, the frame, where the back and forth motion goes. This is the first time I ever actually sanded these guys. Normally I just grab them, toss them in things, let it rip. Frankly, I'm kind of disappointed I didn't go with a slightly more gritty sandpaper to start out with, because this actually looks decent. I wasn't sure what was going to happen. Just chucked it up in the drill and went at with the sandpaper. I was surprised it turned out this well. I was honestly ready for disappointment. So here you can see I left that tail end undone on this one, just so that you can see the difference between sanded and unsanded. So that's how it started out with, and that's how it ended up. So I will definitely be doing this from now on because it is simple enough and I am happy with the results. So something really interesting happened here. Oh, okay, I see what happened. I was gonna say, I just started up another instance of Fusion because I didn't see it in my taskbar, but it looks like its icon is just for some reason dead. I've got a blank icon here, and anyway, point being, so cut some of the extrusion up. Well, I cut the extrusion up that we have sizes for at any rate. I was considering holding off on that just because I'm not sure if we're going to make any changes, but one of those things I'd prefer to get it done sooner than later. So, I don't think, because we already have the frame set up, you know, and all we're doing is adding the kickstand to it and the bottom part, I don't think anything will really change that will bite me in the butt for this one. And one of those things, any of these pieces in theory could be used on the arcade stick, so it's not necessarily a waste, which is a nice thing. Meanwhile, for point of reference, this is our current size. Now the interesting thing here is I'm looking at how this is lining up, and yeah, it's interesting because I know I could have swore I cut this guy an 1/8 of an inch too long, and I was like, alright, whatever, it will just be sitting out a little bit. These legs will be sitting out a little bit, but at the moment it actually looks like it is correct size. Here are the rails in there, and I cut these guys an 1/8 of an inch short, and actually it looks like these guys are more like 1/4 of an inch short. So something a little weird's going on here. Oh, actually, no, yeah, I did use the inside face. So yeah, I'm not really sure what is going on here with the sizes, because again, based on the CAD, this guy, or actually I guess it makes sense that these guys are longer, but this guy right here, this guy should be shorter. Yeah, okay, so if I did make this an 1/8 of an inch long, and then these guys are up to 1/4 inch, okay, that makes sense. Anyway, my point of having it here on the desktop is so that you can see relative sizes. So, one of those things, that's the size of my hand. Again, I'm using this for small parts, that's why it's this size. We are not using this for big parts, at least I don't think we are. At any rate, I have very small parts that I want to put on this. And frankly, this is bigger than I need for those very small parts, but I figured I could get some more utility out of it, which is why we made it this full size. So anyway, that's where we're at. Is there anything else I can compare it to that you might recognize? I mean, here's my calipers. So just one of those things. I know my hand isn't necessarily, you know, demonstrative of everybody else's hand, so it might not give you a good idea. My point being, the whole entire point was that it is a bit on the small size, but it actually is larger than I need it. So I'm happy with it. It just, if you were expecting it to be a lot bigger, because, and if I hop over here into Fusion, it frankly looks really meaty and big in the CAD. You know, that is not the case. One other thing is I still haven't made up my mind on how this guy's attaching, whether or not I want to try to use angle brackets or whether or not I'm going to just drill and tap. Still coming up with that one. Obviously this end right here will be drilled and pinned. So Regardless, let's get on with it. So we need the kickstand yet. And the plan on the kickstand. So I was talking a little bit yesterday about allowing it to swing, because in theory it's going to just be a long arm, right? Allowing it to swing on the outside of the base. Or that wasn't yesterday, was it? It was a couple days ago. I didn't stream yesterday. One of those things. Probably just a bad idea, so I'm just going to ignore that one. So if I don't, if you notice me not doing that, that is why. The other thing I was thinking about is the kickstand makes sense so long as the leg is long enough. The problem is getting the leg is when the leg is too long, right? So if we rotate this up right now, point being, and it looks like some of these guys are obviously not constrained. I'll cry about it. So if I make a leg right here, that is yeah, capture position. This long, let's say, right? If I rotate this down, this leg is all of a sudden through the floor, right? Which means that this leg actually needs to pivot up like this, or down like this, technically speaking. Either of these ways. If it pivots backwards like this, that actually is... it doesn't make that much of a difference. But my point being, where I was going with this is, as you can see now, the force is heading in this direction. The downward, pressing down on it, as we're sanding, all right, is going in this direction, which is not really great for this. This really wants to stay at a right angle to this in order to be working properly. Unfortunately, it is one of these things where I don't think we're... So we could do a telescopic kind of deal, right? And that might be okay. I'm just not completely sold on it. Yeah, maybe it ends up being alright. The other options are just to live with it. Both of these sides, in theory, will be T-nutted to the frame, so it shouldn't move. Assuming my T-nuts are tight enough, it shouldn't move anyway. So that actually shouldn't be too much of a problem, is this other argument. And the final argument is... Well, the final argument is that... Let's see. Basically, what I'm thinking is... I was thinking there was some play here. I just don't know whether or not it's really viable, how much play. Just because, so for this length, right, this can fit, as you can see, anywhere in there. And therefore this angle, can be adjusted. So I was thinking there was some play in it anyway, so it may not be that big of a deal. One of these things where I'm thinking to just run with it, to just let it be and not do anything special with it. Less because I'm trying to get through this, and more because I don't have a good idea, aside from the telescoping idea, and even the telescoping idea is a meh. So there's a bunch of different ways we can go about that. I'm just not completely sold on it, frankly. So it's one of those things between easy and potentially consuming a bunch of time and not getting a good result. I think I'm just going to go with easy. So one of those things, we'll put a hinge and a T-nut slot on both sides of a piece of extrusion is what I'm thinking. And then it's one of those things, the hinge will allow us to adjust the angle in order to fit underneath whatever angle we have here. And the T-nut slot will just hold it and keep it from sliding. So again, even if it is at this wonky angle and the force is coming this way, the T-nut and the hinge, so long as the hinge does not break, the T-nuts should keep it in place. So even though we're pushing down, if it can't move, then in theory it's rigid. I mean, it's not very rigid, but in theory it's rigid. So I've got a little bit of a snack, so while we're setting this up, I'm going to go ahead and munch a little bit. Alrighty. I am done my snack. So, anyway, we just got this leg in here. I'm thinking about how I want to do the hinge. Also, you'll notice that I did this really short. So, recall when I said there was adjustment available, right? So in this situation, what I'm thinking is that if I make this just so long, right, it doesn't necessarily matter whether or not it's connecting here or to the middle or towards the end. The only thing that changes is leverage. And so it matters a little bit, but assuming that it's not going to break, then it doesn't necessarily matter. And furthermore, if I rotate this up, let me hop up to somewhere I can rotate it at. There we go. So if I rotate it up, you can see how, again, the only thing I'm missing out on here is leverage. So again, assuming it doesn't break, so long as it connects to right there, even if it connects down here, technically speaking, it should more or less work. And furthermore, we can always make the kickstand longer. So we could have the kickstand running from here to here, and in this situation where it is up like this, then obviously it's only going to reach just so far, but that is further up, past the halfway point than if I made it smaller. So one of these things where I think we can probably get away with this, with keeping these legs short. I think I'll see what happens. Basically, I'll go ahead and leave a drop uncut, just use some drop from somewhere. I don't actually have any right now, but maybe by the time I get done doing this kickstand, I'll have some. And then I'll see how it feels, once we get that set up. So, in other news, I'm trying to figure out how exactly I want to design these hinges. Yeah, you know how we were using the screw to adjust angle before on the other design? Part of me almost wants to introduce a something to, I don't know what. I was going to say screw, but I don't know what, to hold the angle at, rather than just trusting, physics. Because it's one of those things, yeah, I think I should. Like, in theory, if both ends are fixed, then I was going to say it can't really move if both ends are fixed because it has to slide, in order to keep on moving. I wonder how true that is. I mean, I may be overestimating the holding force there. So having a screw or something like that would help. The biggest problem is how to position that, because we got the extrusion in the way. In theory, whatever extrusion I put here, whatever size extrusion rather, is going to be in the way of any mechanism holding it in place. And furthermore, I only have just so much height here, right, to work with. This is, in theory, if it's laying all the way down here, it's one of those things. It probably will never be laying all the way down here, and even if it is, frankly, I can always just stick a book or something underneath it, for the specific angle, because it's, flat 180. So, I mean, this is, what, 0.6 of an inch or something like that? Yeah, 0.6 of an inch. Good me. Good job. So, that is not a lot of space, obviously, to jam something in there. Again, may not be necessary. 15 millimeters is actually less than 20 millimeter extrusion, which means that, technically speaking, our kickstand doesn't even fit right here. You can't actually fit another piece of 20 millimeter in this gap right here. So that conversation is probably not worthwhile. Let's see. You know what would help? Okay, that's what would help. The only question is how to do it. So the extrusion goes off on the edge and goes up and down and then fastens onto there. That would be much better than having a hinge. It's just a matter of how to get it there and how well the T-nut is going to hold it is my only two concerns. The reason I would not do it there is because obviously all the forces are in parallel to that. So this is the kickstand is no longer directly underneath the supporting it. The only counter argument here is that, again, in many of the angles, our kickstand is not actually perpendicular to this to the frame at many angles because of limitations. So it may be a little bit of a moot argument. Yeah, you know what? It's one of these things. If I have the extrusion out on the side here, I can actually cut that extrusion at any height, which is very useful, which means that I also can choose not to cut it. I could use, again, a drop just sitting around, which, again, I don't have technically speaking right now, but we can probably come up with one. So I think that's where we're at. I think I like that idea best. Okay, yeah. I like this idea best. Boundary fill. New component. Turn them off. Modify a line. Grab a side. Grab a side. Yeah, I'll just stick them dead center. In theory, dead center. Obviously, that did not end up dead center, but that's okay. And we'll flip this. Yeah, you know what? I was trying to decide how I wanted to get into position. It is just easiest, I think, to actually grab. So let's turn that off. Grabbing these middle dots is probably the easiest way to get into position. There we go. And then modify a line. That and that. And now we are off. Honestly, it's okay. It can be there. It's not that big of a deal. So, let us go ahead and extrude that out. Like I said, it could be extruded out any distance. So we'll extrude it out like 100. And I forgot we got to go in and join. There we go. Captcha. And join. Okay. Now, this technically, I guess, should be up more. Nah, it doesn't necessarily. I'll just move it out. Do I move it out? Because this has to connect to both of these, right? Turn that back on. Got to connect to both of these. Actually, why is that not in line? That is fascinating. Why is the leg not in line with the frame? Huh. Okay, I guess it's not because we're aligned to the outside of the middle frame. I assume that's why. Yeah. So back to, I got the plastic here and a little bit of offset, so that's why it's not aligned. Okay, that makes sense. So anyway, back to our problem at hand. How do I want to connect this? Because it needs to be, so it needs to be rotatable. It has to be able to rotate, and it has to be able to tighten down. It has to do both of those things. I guess maybe I move it up and then I can cap it. I can put a cap there, a plastic cap, and have it sit in the plastic cap. And the plastic cap can rotate and rotate on a T-nut. That way I don't have to fasten. Well, I even then could tap the... Okay, yeah. Let's start drawing this so that you can see what I'm talking about. So, we are going to come in here. This is kickstand leg. New component. Bottom joint. And I'm going to draw it... Oh, interesting thing. I saw a video today, so I knew about this. Let me actually, hold on. Before I continue with that thought, let me just get myself set up here so that I can actually show you what the video was talking about. That, well, come in here. So the video was talking about 3D Sketch, which I turned off forever ago. It was on, if I recall, when I first installed Fusion, and I didn't particularly like it. And it was a video, the video I saw was talking about how useful 3D Sketch is, and he used the idea of a frame. So he used a frame, and then he used the pipe tools, I believe. I believe he used pipe. Now, when I first started using Fusion, I actually used pipe all the time. But I've been finding that, personally been finding that to be not very useful. And it's one of these things back to sketches do not have timelines on them, which make them very unreliable. And therefore, I kind of disagree with the video. The video is like, oh yeah, just make a sketch and have the sketch, you know, be 3D. And so, for example, let's use this frame as an example, right? So this frame, basically, you could imagine me drawing a line through all this frame, okay? For the sketch, and then in theory I could go ahead and then, for example, sweep. Where's sweep? There we go. So I could sweep the extrusion through all those lines. In theory, that's something I could do. My problem is that if I need to go back in time with one of the lines and change how I did it, that is significantly more likely to fail than if I had to go back, delete an extrusion, or change an extrusion. Actually is a better example. Deleting extrusion obviously is going to raise errors, but if I change the shape of an extrusion, projections and whatnot will catch up easy. And it's the guy had, for example, fillets in his sketch. Let's get back to sketch. Fillets. You'll never see me put fillets into sketches because that breaks all sorts of constraints. And it's one of these interesting things. I'm bringing it up because it's an interesting idea and maybe I should give it more of a shot. But I'm bringing this up to generate some conversation because I honestly am not sold on it. But it's one of those things, a guy went and made a video. So at least, you know, give it a little bit of consideration is where I'm at right now. Boo, 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 boo. I'm thinking maybe I should have drawn this from the down angle, but we'll probably be alright. This is going to be two overlapping sketches of what this is going to end up being at this point. This is going to be both the T-nut holder and the extrusion holder. And wall thickness, I've been using 6 in the sketch, right? But I want to go 3 because it's a T-nut. So, actually, sorry, one second. So, I was going to say my M4s that I use a lot, they're M4 by 8s. And I was finding that obviously I could not use them for situations where I went over 3mm wall thickness because they're not long enough. And that is why I'm suggesting that I'm doing 3mm walls here, But the fact of the matter is that for this kickstand, maybe it's better that this kickstand is, let's say, an N5 T-nut or N6 T-nut, 6mm T-nut. I actually don't know. Let me check the box real quick. Let's see. Where are my T-nuts at? Okay, yeah. They do one of these things where I wasn't sure because you say M3 bolts, right? You say M3 bolts, but you would say 3mm rod, even though a rod and a bolt is basically the same exact thing, just one has threads. So I wasn't sure whether or not they called these M or 3, M3 T-nuts or 3mm T-nuts. I wasn't sure what the terminology was, technically speaking. But now I know. So on the inside here, we are going to need 3mm for walls on each side. So that's 6 plus 20. So 26. There we go. And extrude this guy out. Minus, let's see, minus 8. Again, this is probably 28 rather is what I meant to say. This probably would have been better done from the bottom, but oh, actually, you know what? This should be 23, 26. I forgot I need walls on the inside, and I should do the second extrusion separately. Bottom joint. Oh, the other thing is actually because this rotates, this should not be collinear because that is going to scrape the ground. So let us give ourselves like 5mm of clearance. Yeah, we're technically still in there, so we should be all right. Finish. I'm trying to think. Now I'm thinking about whether or not there's a way to get 2 T-nuts on here to better hold the angle. I don't think there is, but it was an idea. Definitely an idea. Basically, because this is going to be rotating, I don't see a way that I don't see a non-trivial. I don't see a trivial, rather. It seems very non-trivial to add the second nut. So the one nut is always going to be center right here because it can rotate. But the other nut may actually be, best positioned. For example, if we go far enough this way, if we rotate far enough this way, off the bottom of this box right here, which obviously is not going to fit underneath the box when it's vertical. That's the issue I'm seeing here, why I'm not doing it. So let's see, 4 plus 3mm on each side is some amount. 4 plus 3mm on each side is 10. Math on stream. Minus and join. Okay. And now I am going to have to come back up here. Again, probably would have been better off to sketch it from the top to begin with, but that's okay. Sometimes we do things differently. Shoot. That was silly. I was thinking this was a 20 by 20 is what I was thinking, but the walls are 3. And that's what I'm dimensioning right now. I don't have to dimension the other ones though. I can do 20 here and 20 here, and those should come out to 3. 20. And actually, I didn't need this 3mm down here, did I? That was kind of derp. So let's check this really quick. Whoops, not that. I wish my in sketch inspect thing actually stretched the whole length. Like, I can stretch it this way for some reason, but not this way. This seems a little silly. Anyway. Oh, 3mm stuff. It says it right there. Okie dokies. So that is correct. And 2 distance minus 3. 2 distance, 3 minus cut. And then we can toss this in here. Yeah, I mean, one of these funny things where I know I've said this 3 times now, but I'm kind of kicking myself that I did not just start from the top here, because now I've got 2 extra sketches, or 1 extra sketch that I don't need at any rate. M4, and actually that does not line up on there because we are offset from the bottom, which makes sense. Not center here. Grab that guy, 2, that guy, that guy, that guy, that guy, that guy, that guy. Construction lines galore. There we go. Extrude. Let me turn my fan off really quick because I am getting cold. Alright, fan. Alright. The next thing to discuss is that this is pretty close to this edge, which is something I can only change by making the it still ended up 3mm below. Alright, I'll take it. I'll take 3mm. That's fine. So this is only going to be able to rotate just so much, obviously. Let us see. I'm going to go ahead and put these together, and then I'm going to rotate and see where we're at. The other argument is that I should never have to rotate backwards this way. Actually, which means that, in theory, I could have put the other hole here. See, I was worried about... Alright, you know what? I'm going to do what I said I was going to do and get that joint in here really quick so I can show you the rotates. I was worried about rotating towards the back, but again, the back is not going to be used probably. We're probably not going to rotate back, which is something I mentioned. So, probably not something that I should have been worrying about. Oh dear, we cut the extrusion. Whoopsies. Let's fix that. That is incorrect there, sir. Thank you. Kickstand. Okay. So, capture position. As built joint. Rigid. Okay. Whoops. As point joint. That. Revolve. There. Okay. So, anyway, point being is that this probably never happens, right? So, the fact that that's the box down here is going through the bottom ledge is probably not a problem. And the reason this is not a problem because even in this orientation right here, with it laying straight down like this, the joint I was going to put up here was going to be able to slide up and down the extrusion. That was my idea. So in theory, this joint just stays right here. The clip that holds it to it just stays right there. And then when this rotates all the way up, try to grab this joint. There we go. So when this rotates all the way up, this, in theory, this could slide this way. This could slide this way and try to catch up. That's definitely a thing. But alternatively, we can just rotate forward. So it's one of these things where probably not a problem that we can't rotate backwards, and in which case it is less difficult to put an arc on here for the second bolt. So as we rotate forward, then we can get that second bolt on the arc. Well, that second bolt will be on the arc rather, and we'll be able to attach it. So that was a possibility, and we haven't done it so far. We'll see whether or not we need to. Okay. So let us see. So my problem here, the problem I'm running into, is kind of the same problem that I had here, where I plopped this in the bottom. The reason I plopped this in the bottom was because I couldn't think of a good way to tighten it with the T-nut to this bracket. We're having that problem here because, in theory, the bracket that I'm about to put between these two needs to move up and down on both this guy and that guy, on both the frame and the kickstand, which means that it needs to be tightened on both sides, which is a little bit of an issue. I guess what I can do is, if I make an L-shaped bracket, yeah, alright, so if I make an L-shaped bracket, then in theory, I believe I should be able to always reach the bracket. So if the bracket was square, like this, right, obviously the side that goes into the middle here would be obscured by this frame. But if I made an L-shaped bracket, then the top part up here could be fastened and the bottom part down here could be fastened. And if we move everything, if I imagine this tilting forward and this guy tilting up, even then they should not overlap. This frame should not overlap the top of the L. So I guess that's what we're doing. And the only question is, how do I want to go about designing it? Because, well, it's one of those things I might just have to use bigger bolts in order to take up the space, because I kind of want it to be one solid bracket. I don't want to have it be thin and zigzag. So if I had 3mm, this is 6mm right here, this bracket that's holding this, and we know that that's how far off. That's what I discussed earlier when we were talking about this guy. Plus I've got another 3mm right here that we're off, which I should probably fix because that should be 3mm. So let's fix that really quick. So this should be 23. Whoops. 23. Finish. That shouldn't break anything. So anyway, point being, well, it's going to break that, but we can fix that. Point being is that we have 6mm plus 1. We have 6 plus 1 between these two. And I kind of want to fill that all up on the one hand. On the other hand, it is a lot of extra plastic, and my bolts no longer fit. My T-nut bolts no longer fit. So that is a little bit of an issue, but it's one of those things that may not be enough of an issue to really complain about. Plus I can countersink the bolt. I can countersink the bolt to make up for it. Yeah, you know what? It's really not that big of an issue. This was back of left leg. And now I need an inside of extrusion. And Control Z because that should be on here. And we project out everything and we should be good. Rather simple design here, not too complicated. Only complicating factor is how much we want to do and whether or not we make the sketch on the wrong object. Top joint. Give me this back, please. Thank you. Next up, after we finish this, we will be doing the plate. We still need to do that. As you can see, I got the LMUs in here. LMUU linear bearings, 8 millimeters. LM8 UUs, technically speaking. And they are the medium size, which means that they are 25, no, 12, 15. I think they're 15 millimeters long. The large ones I think are 25 if I recall correctly. And then the small ones, were they 10 or were they a different number? I cannot remember. Okie dokies. So RL, again, easy peasy. Just need to line it up and then we will be groovy. Center this. Center this. Whoops. Nope. Center like this, please. And then you can be like 10 millimeters. You can be the same size. And actually, the head on the M4 was 7 millimeters. I measured it last time. That's why I'm trying to remember without looking, because I've been using a bunch of these and therefore I should remember, so that I don't have to keep on checking. Let us see. Let us see. Yep, 7 millimeters. Good. I know it. And it's 4 millimeters tall. So, let us see. 10, 3, 3, and 7 is 13. And 13 for our 3 millimeter walls around the socket head, because we are countersinking the socket head was the plan. This distance here, let's see, how much do we want it to be? And actually, you know what, I don't want that distance. I actually want this distance, because in theory, all right, because these are 13, the thing is 20, but it's only 10 from center line. So 10 from center line is 13 and a half is 6.5, so it's 4.5 past here. So 4.5 past here gets us clear of the extrusion. And then we want probably another 13 after that. So that's like 17, 18. So 18, and then we want another 3 on the other side for the extra plastic. So that's 21. So let us call it 25 then, and to be safe. And this guy will do the same thing. That is not how numbers work. There we go. Lining up the stuffs. Lining up the stuffs. That collinear these guys. And actually, alright, so I normally don't do coincidence on points, but it actually almost seems worth it here to do this. No, that's definitely not worth it. That is not correct at all. I take it back. That was not correct. Okay. Back to the collinears. There we go. That's much better. Although, turning these to construction lines is proving a little bit difficult. There we go. And now the last thing we need to do is draw our socket heads and our M4s, and we are good. Do. So we have 4. Oh, that was pretty good. I was pretty close to 4 there. 7. And 3 millimeters of clearance. And as you can see, I did my math correctly because it fits. Nice. And equal sign on these guys to save ourselves a little bit of typing. Now and in the future, if we ever have to change it. Alright, there we go. So the tricky part here is that one side is well, both sides are countersunk on opposite sides. We are up against the leg right now, kickstand leg. So we do want to be heading this way. And honestly, we should probably just go to object is probably how we should do this, just to be safe. Okay, and now we want, for the holes, we want, what did I just click? I did not click the correct thing. All right, turn you off. That, and that. This side, you know what? We'll just do all of it. We'll do all of it, and then we'll do the countersinks afterwards. That's easy to do, easy enough. All right, so this countersink is on this side, so that's -4. Well, -3. It will stick out a little bit. That's not that big of a deal. It might matter a little bit just because it will be scraping in theory against this side, but probably won't matter that much. This guy, however, assuming we can get to that profile, there we go. This guy is from this side though. Object -3, or not -3, and there we go. Boo. I feel like I did not remember to bring over a couple colors. The colors that we made when I forgot to do pink. Speaking of which, we'll go ahead and make that pink. So I gotta remember to go back in there and grab those colors. Otherwise, this is clearly directly inside of the what you call it, which is not correct. How did that happen? We did 2 object. How did we get 2 objects wrong? Okay. Okay. I have no idea how all this turned out so wrong. This one's not 2 object then. Profile. Okay. That was a hilarious blunder. Alright. So there is that. We get this slid down. Let's get that. Well, we loosen them both up. Then it can slide however the heck it wants, frankly. Doesn't necessarily matter. We can also loosen up this bottom guy. And that way it can pivot if it needs to. The fact of the matter is that if it doesn't pivot, then this extrusion will be blocking that hole. But so long as we're pivoting, then it doesn't necessarily matter. Alright, yeah, I'm just going to go ahead and kickstand, create mirror, left leg, components left leg, across the center, and we should be good. And now I can modify our rigid group. There we go. Rigid group, no children. That guy, and that guy. The other guys, yeah. It's technically not a rigid group, technically speaking. I leave it alone for right now. I'm trying to get done. Not necessary. Work plate, and I think I'm gonna make a new work plate object. Whoops, I meant to do top frame there. Top frame. Okie dokies, and now I can turn this back to work plate. So technically speaking, this should... So we can do this from center because we do need these profiles here as well as these profiles to make sure we're over top of these guys. So we can do this from center, and that would make sense. Center on the y-axis, like this. That would make sense. Alternative is to put a plane in on top of this frame right here and draw the plate and then come back for the other stuff, but that seems like extra work, so we're going to go center. One thing I should note is that our plate is going to run into these guys, which is actually something I recall saying last time. The solution for that So there's a couple solutions we can use. One, we can use longer legs down here. That way it's always tilted down and we're always keeping it below here. So instead of having these L-shaped brackets, I could just put a cap on top and then the cap is just always there. Again, I was trying to get away from that but it is a solution. And this is part of the reason why I wanted to put the kickstands behind, now that I remember. One of those things, it was just very difficult with only 15 millimeters to fit a 20 millimeter extrusion in there. Quite difficult. So I think we're going to cope with it for right now. I think we're going to cope and we're going to see how bad it really ends up being. Again, the somewhat easy solution is just to extend the leg out far enough out the backside or rotate down. But again, rotating down, we end up hitting on the bottom here because we don't have enough space. So that's not necessarily a solution. But if we moved this basket up on top of this hinge, above this hinge, that would allow us to rotate all the way backwards. Rotating forwards, if we rotated forwards right now, we would have like zero leverage on this frame, which is why I was trying to avoid that. So we have potential solutions. We'll see what happens. The fact of the matter is that I don't have to edit the CAD in order to add in extra length on this leg. I can just do that in real life. So it's not that big of a deal. So here are these guys, and then here is the top face of that guy. And now we do the platter. Turn all the rest of this stuff off. Sanding plate is actually what our object should have been. But, oh no, that's the bottom. Sanding plate is the bottom. I take it back. Yes, I know what I'm talking about. I do, honest. So, we got a plate right here. We probably want to... Let's see. How do I want to set this up? I guess I'll do this. And tangent these guys. I want a reference off of these guys. Actually, you know what? No, we don't need that. We'll just... One of these things where this arm right here, we can probably reference off of instead. So I can just back that up like 5 millimeters is fine. And off the backside, and that should be good. And then for the thickness of the plate, 4 or 5. Let's go 5. Just because I got 5s in all the other numbers. And then clearance over top of this only really has to be like 1 or 2. Let's do 2. Just to make sure we clear. And then we just need to make little attachment points. Try not to intersect the line right here. Grab. Attempt to grab. There we go. That's a right angle. That's a right angle. That centered on that. That centered on that. Whoops, that is not the correct line. That's centered on that. And then we just go tangent, right? I'm pretty sure that is correct. Well, all right. So we have this here, right? So we could just use that. Normally you just zip tie it and don't worry about it. You just zip tie your thing to the rollers and then it's no big deal. But let us go ahead and, for the funs of it, cradle the rollers instead. And by rollers, I mean linear bearings. And we'll turn that back solid so we can extrude. And let's go. So here's the deal. Whoops. Don't do that. The deal is that we have a lot of freedom on how big we want to make this, and these linear bearings can spread out a bit if we want them to, and we have overlap over here. So in theory, I'm going to want these bearings kind of, so there's a balance between having these bearings close to the edge so it provides support, rather. So the closer these bearings are to the edge, the more support it has on the edges. However, then we can't overlap this edge, this frame right here. And the whole entire point of having this up a little bit is so that I can go past the frame to give myself more swing on the sanding. So we have a little bit of a decision to make. Two-sided. I think, you know what? I'm going to leave these where they... Nah. Alright. Let us do to object. Distance to object. What if I do this? So that is the plate. I can move these guys out a little bit to give it more support. And then so is 160 millimeters to attach my work more than enough? And I think it is. Yeah, let's run with this. Let's just run with this. And then I'm going to go ahead and grab these guys is what I'm going to do. I'm going to actually come back here and move them before I attach the, what you call it? Components. And let me do the translate. Yeah, 10 is fine. And I'll just do that for all of them. Component translate, good. 10. Cast for position, and then I'm happy with that. So we go back to the end. Come back up here. Go to the end. Come back here. And now extrude. Extrude the little holders, cradles. Actually, I have that tangent. I probably shouldn't have that tangent. That is probably not intelligent. Turn these guys back off. Actually, yeah. Okay. I was trying to figure out how to determine it, we have two options. We can just toss a line in here. So toss a line, make that tangent, and then do my 3 millimeters. Yeah, a line is not bad. And then over here, we can actually just go equals. There we go. That was pretty simple. Linear rails. There we are. Whoops. Not open. There we go. From object. There. Distance to object. There. And looking good. I think that's looking good. And actually, I will do the top and the bottom at the same time. That makes sense. And then I will mirror them. Makes sense, makes sense. Mirror. Not bodies, though. That's silly. Features. There we go. Across the midplane. And it did not work. And optimize is not going to work. Optimize worked. All right. Okay. Optimize worked today. Fascinating. Next thing, actually, let us come back here. One of those things, throw our little bit of offset in here. Offset here and here. Minus 0.1. And it's 0.1 only because... instead of 0.05, because I don't mind if it's a bit loose. And optimize appeared to still work. That's good. And the next thing, I have plenty of space, as you can see in here, so we will be putting in zip tie tie-ins. And normally the zip ties, I believe, go around these circles right here. So that's how I'm going to design them. Linear bearing attachment. Project. And I'm pretty sure they can be right at the top. I don't think there's any reason why they can't be right all the way top aligned. And the only other question is whether or not I want to put a little bit of an indent in the rest of the side, or if I just want the hole and just say the hole is good enough, which frankly it keeps things simple, so I'll probably just stick with that. So one of those things, probably should have projected things and turned them into construction lines before I put my boxes in here, but we in a hurry. We in a hurry to get done. Please, thank you. So this is gonna have to be, oh, I do not have a crossbeam in there. Okay, there you go. That center to center, right angle. Pretty simple. And what do I need for a zip tie? Where's my bag of zip ties? 1 second. Fortunately, I just had them out the other day when I was fixing up the Prusa. Back to I did a whole bunch of cleaning on the Prusa last Sunday. Got it all nice and spiffy. These smallest ones, I believe, are the ones I will be using. I don't see any reason to use anything bigger. So these guys need, they're like 1.2-ish. So let's make it 1.75. Let's make it 2. Let's just make it 2. That way I don't have to worry about it. Not even good. This way I don't even have to offset it. I don't have to offset it. And likewise, Let me double check the width. So the width I'm getting about 3 point. So I'm coming up like 3.45. I'll call it 3.5. But let's see what this guy is right here. Okay, that says 1.1. So my zip ties, I guess, will not be sitting inside of that trough completely. So let's call this 4 then. I said it was like 3.5, so we'll call it 4. Doesn't bother me any. Although that is pretty close to the edge. Let us see. What was that? 1.3. Yeah, so pretty close to the edge. I might want to... So the more I expand this out the edge... Yeah. Let us see. Because I don't really want to send this out further, because that again takes away from our swing. That takes away from the amount that we can move. So, let us consider. The other option would be to offset these, to not have these centered on here, to just go like this. Yeah, you know what? Maybe that's what we do, because we aren't getting dead center of these guys anyway. I mean, because we can't fit in these guys, I should say instead. And then I just call this 2 here, and we just say good enough. Like that. And then the left-hand side of the zip tie is just a thing sitting against that edge. Yeah, I guess that's where we're at right now. It's what we're going to settle for. So, I mean, it's one of those things. At this point, this is the only thing that matters. These lines actually don't matter at this point, which is fine with me. Alright, yeah. We'll just go that way. That is how we'll do it. 2 millimeters. 4 millimeters. 2 millimeters. Collinear. And that was kind of silly. Delete. 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 Actually, this one does not necessarily get deleted. However, it does do this. And likewise over here, you should just be that. And we'll delete you. Delete you. And equals. Equals and equals. Equals. And equals. That way I don't have to worry about any of the numbers later on. Huh? Why is this not working? There we go. Okay. Confusing me. That guy. And we good. Awesome. Boom, 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 and boom. Distance all. Turn the bodies on. Flippy floppity. And make sure we're not cutting anything we're not supposed to. Cool. Groovy. Alright. And that is our plate. So it's one of these things. I was trying to think of this, how exactly I want to hold things onto this plate. Part of me actually just wants to hold on by hand. The other part of me doesn't really see a good way of consistently holding it. I almost kind of should clamp it with something, you know, get a vice grip or something and clamp it to it is almost what I should do. Obviously that takes up too much space and won't really fit, but I will think about it. I don't think I'm going to put any mounting holes in it just now, any tie down holes rather. But that is an option. Putting tie down holes is definitely an option. Hold down holes, whatever you want to call them. Yeah, I think I'm going to leave it alone for right now, and if we have to, we'll revisit in the future. brown. And now we should be ready to do the last part, which is the sanding plate. And that only needed a modification because all it is just a flat plate. So there's our sanding plate. Again, it is not actually going to be bolted back here anymore. It is going to be adjustable along a set of legs. So we will go ahead and get those in there. I'm going to change this to bottom frame. Open it up. We're going to come in here. Whoops, not that way. Right here. We'll come in here and delete these holes. It was my plan, my intention. So we're deleting the holes because we're not going to be mounting like this. Actually, you know what? We won't be mounting like that, but we can leave the holes because it still needs... Actually. Yeah, I will delete the holes. I take it back. I think I'm going to change this to wrap around the edges. That way it has a flat top for the sandpaper. Again, the sandpaper is going to have to be held down somehow. Actually, you know what? Maybe we do both. Maybe we leave the holes in there to mount the sandpaper with. So I'll go ahead and print out some clamps to hold the paper down with. So it just clamps down to here. And then we have the extensions on the side to attach to the, the rails. Okay, I'm content with that. Let us turn the rest of this off so that I can have a better look at this because I see that it's not constrained right now. And furthermore, this bottom frame, this extrusion right here, this support thing, frankly should probably go. So let us finish, delete that, and then I should have gotten a complaint here. This should be mad at me because it no longer has a projection. Okay, I guess that projection was the middle frame. I guess that's what that was. That's why I'm not getting a complaint. What are you guys? Yeah, you are not attached to anything. You evidently are. No, you're not. Okay, gotcha. You guys are not attached to anything. Very zen of you. All right. And since these guys are now for the sandpaper, I'm going to put them at the back, and then we are going to... Yeah, see, I don't know if I'm even... You'll recall I talked about not doing offsets on the hexes anymore because I wasn't finding it necessary. I don't know if I'm going to do offsets on the... if I'm still doing offsets on the socket heads either, which is why I didn't put offsets on the brackets for the kickstand. So that's where I'm at with those guys. That's why I didn't put the offsets in there. The other thing is that these actually are not socket heads anymore, actually. And evidently I did the whole second, so delete that. This is now going to be the hold down, so I actually want... Give. Hexes is what I want. I want hexes. And since this is hold downs, I will make these... you know what? Alright, back to staying consistent on the hardware. I'm pretty sure I'm using M4s for everything else, so I'll make these M4s as well. And I meant to have this right angle, that way it's constrained. And I didn't. Point being. Crap, I rearranged my... There we go. Okie dokies. And M4 hexes. Let's check because I do not know. M4 hexes. I'm thinking 5.5. That's what my bet is going on. We are about to find out. Are these 5.5? Nope. Oh, they're 7 just like the socket heads? Well, actually, you know what? That's funny because I think that tends to be the case. I seem to recall the 3s being the same exact way, where the socket head, the button head was a little bit smaller, but the socket head was the same size as the hexes. So that's something I should remember. Point being, this is parallel to that, we can say, and this is, whoops, this is a 3mm offset. That did not work the correct way. What is that? Oh, you're not concentric. There we go. All right. You are equal. That is good. So I don't have to tell you what to do. I just got to set him equal and then parallel. And per our usual arrangement, this is technically constrained, but Fusion does not like that I use the equal sign on the hex. That's more or less what I figured out since last time when I was complaining about it. I'm pretty sure it's because I used the equal sign rather on the hex, that it decides that it is not actually constrained, even though it is technically constrained. May as well do both. Minus, and these guys, any guesses on the thickness? I'm guessing 3. Yep, it's 3. Although it is a +3. Okay. From object. Try this again. There we go. And again, I will print out little clamps to hold down the sandpaper here and here. And what am I looking for? I'm looking for mid-plane. That's what I'm looking for. And all of this is... Let me Control Z this, because all this should have been on a new object. Sandy plate. Yeah, it's okay. I forgive you. Cut. Cut. Alright. Cool. And now we hop in here. Get that mid plane and then mirror it over. Mid plane. Mirror. Just has it going the wrong way. No, actually it's not going the wrong way. It's cutting all. I wonder if that means that I was actually also cutting. So this guy's actually dead, right? So I shouldn't be cutting that. So the only other option is that I was actually cutting the bottom frame, which is what it doesn't look like it. So, okay. Gotcha. I don't know why, if I don't have any objects up here, why that one turned out as blue-yellow. I guess I do. Because the other ones are blue-yellow, that's the only reason. It's a little bit silly, but because it didn't actually make any modifications to anything, but I guess I understand that is the reason. So let us see this really quick. What is attached here? That should just be those guys. That is just those guys. I don't see a collinear here. Is it this guy? Okay, it is that guy. I wanted to move this off is what I wanted to do, because we're going to be putting the legs on the side. And actually, you know what? Rather than do that, we'll just do that. Okay, that is fine. The next thing to discuss here is how wide we want this sanding plate to be, because again, now I have a full range of movement on the linear axis on the sanding on the workpiece. So that being the case, I could make this a good bit longer and have a good bit more sandpaper. And honestly, I really should if I'm going to use the whole bed. If I'm going to use the whole bed, then this really should be the full length. So let's come back in here and fix that. So that instead goes collinear with that. And then we hit OK. And now let's check what the size is, just because this does need to get printed. Alright, that's just barely within range of my Prusa, so I guess it's alright. The only other question is, do I want to put a hole in the center now for an additional clamping force, which I think I do. So let's toss that hole in here, and then a hex. And we don't need the outer tangent because we don't need to be tangent anything. Whoops, that is not correct. I was trying to grab the hex, but I missed. And we'll make you perpendicular to that. Finish. Grab this sketch, and this is the hole on this one, and this is the hex on this one, and we good. And now also this is 2 inches right here. Yeah, that's fine, that's right. I said this was fine because, well, I said it was fine because we were going to cut the stuff down, but now that it's adjustable, there's actually no reason to cut it down. So we might actually want to go like 5 inches at this point. That way I don't have to cut it down. And it should be a little bit more than 5 inches for the tie downs. So 5 inches plus, let's say I use 3 millimeters tie down. It doesn't necessarily matter, I don't think. So that's like 6 millimeters. Okay, so that is that now. Okay, so this, with it being this wide, it actually makes less sense for it to be adjustable. The shorter we make this piece, the more of the sandpaper we can use again, assuming that we're only going against just so much of the surface. So the only other argument, because yeah, these adjustment legs don't make sense if it's going to be a full 5 inches wide. However, if we were going to do larger pieces, which again I'm not necessarily sure we are going to, but if we were going to do larger faces, we would want the full 5 inches of sandpaper available. So it's one of those things. I'm going to leave it like this just because I'd sooner print out the smaller piece than the larger piece. And that is my decision. That is my reasoning, my rationale. And if necessary, I will come back and print a bigger piece. Easy enough. And next, we want the attachment for the legs. The legs can sit in a little bit. They don't have to be all the way out to the edges. And yeah. That's fine. So we can go ahead and do that from center then, in that case, is what I'm thinking. And we do want to be in here, though. We do want to be in here. We'll go ahead and turn that out. Turn that off, rather. Oh, although, I should get the feet in first. That would make my life easier. So, boundary fill. Turn this guy on. Grab him. New component. Bum bum bum. Okay. I guess I'll mirror it afterwards, so I'll bring it down to this edge and then move it manually. Move that guy. And yeah, I think 50 is fine. And then capture and extrude. Although I have to be inside of that component. Okay. That. You can do it. There you go. And let's just call them 100 for now. 100 is kind of short. 150, 200. So we've got 50 right here. Since we have 50 right here, I'm thinking, yeah, let's call 200. That's fine. And then as stated, create mirror that guy. Oh, actually do it up here. Do it up here. Create mirror. Components, that guy. Select midplane. Okay. Project out that guy. Try to get rid of that sketch first. There we go. That is evidently not that sketch. And furthermore, I should be in sanding plate. Wait. Control D. There we go. That sketch. Sanding plate. Center. Much better. That. Turn these guys off. And the bodies. Get this lined up. That on there, that on there, that on there. These are construction lines. These are construction lines. Need this midpoint here, as always. Easy peasy lemon squeezy. Two points, both 4 millimeters. Don't need to countersink these guys. Yeah, 7 millimeters. So the 7 millimeters here is technically fine because that's 4+3 anyway for my 3mm wall. That's all I was putting this in for. But that happens to also be the circumference of the bolt head, obviously. Actually, why am I dimensioning that when I can just hit equals? Equals tangent, tangent, and we off to the races. Bodies, legs, from object, outside of that leg, and we go in -3mm. And joining, and then we mirror. Create mirror. There was an option to run this all the way down to the floor. I opted not to just because I don't want it accidentally being too tall. Otherwise, that would give us more support. So right now, any pressing down on the sandpaper, which you shouldn't really press super hard down on sandpaper, but one of those things, any pressing down on the sandpaper is pressing down directly on the bolts. Now, the funny thing is that 7mm is obviously not correct, and it must be past my bedtime or something like that, because that is only 3mm on one side. So let's delete that and just do our 3mm like we normally do. Finish. There we go. And where's my mirror? Optimized. Nope, optimized broke. Identical. Alright, there we go. And that should be us done, with the exception of the tie downs, which, one of those things, they're pretty simple. I'm not sure whether or not I'll do a bar. So for example, I could make a flat bar going all the way across to hold the sandpaper down, or just do little clips, or use washers. I mean, I could just use washers underneath the bolts there. But anything works. It doesn't necessarily matter. So that should be us done then. Just put in a little bit more color, and I'm not going to bother bringing in the corner brackets. I'm just going to corner bracket this guy down here. That's the plan. I'm not going to bother bringing him in right now. Unnecessary. Rigid group. Not children. That guy, and that guy. As built joint. So yeah, again, pretty simple build, just one of those things, as I said. Only got delayed a little bit because we decided to go crazy. Otherwise, this is where we're at. So I will go ahead, get this printed, get the rest of the extrusion cut, and then put it together, and you'll be able to see it. And I will be able to use it for that other project, the other secret project. So speaking of which, the other secret project, the first secret project, I did say that did get delayed from Friday, Saturday to maybe Saturday, Sunday. That is looking like that might be Sunday at this point, only because I got home and had a little bit of a surprise, and not a bad surprise. It's actually a good surprise. However, it does mean that I have to do a little bit more testing before I show you guys, because things aren't working. Well, I shouldn't say things aren't working the way I expected them to. I was hoping they would work this way, but I had read online that it wouldn't, and yet it does. So it's one of those things. My expectations was that it wasn't going to work that way. It does work that way, so therefore I can actually go and try it out. So one of those things, again, being vague just because it is a pretty cool project and I want to surprise you guys, but look forward to it Sunday at the latest. The reason I can't do it Saturday is because it actually needs a little bit of time to finish itself up. It's not something I can rush. So in theory I might be able to do it Saturday night, but we'll see. I'm saying Sunday to be safe. Actually, the reason I wouldn't be able to do it Saturday night is because I will have to do a little bit of post-processing afterwards. But regardless, that is where the state of that project is. If I have time tomorrow, I don't know if I will, just because I'm washing my nephews in the afternoon. But if I do end up with time, I will get the rest of this extrusion cut so that this guy can get assembled tomorrow. One of those things easy enough for me to print it overnight. With the Stream Deck, the Stream Deck is still having issues sliding. I went ahead and I combined the slides so that they wouldn't cant, and they actually are still canting, which is a bit of a problem. I'm going to attempt to clean up the slides a bit more with Dremel to make them slide easier. That way the canting is less likely, but this may be one of those things. We might be on to a version 3 with this, which is unfortunate, and it's only due to me being weird, me trying to shoehorn this whole entire sliding mechanism in. Alternatively, we could try something else with bearings. I keep on coming back to that and saying, it's an idea. And one of those things, it would be the super easiest thing to do because I've done it plenty of times before. So I know for a fact that it would work. It's just one of those things. I'm trying to avoid it because it takes up significantly more vertical space using the bearings. But it's one of those things. If we don't have a choice, we don't have a choice. Anyway, for the stream animation program, one of those things that is waiting on me. I have not had any time to work on it, working on the other things, so we will get there eventually, just not immediately, just not at the moment. And then Tooth and Tail, we will play some Tooth and Tail probably tomorrow night. Probably not tomorrow. Well, let's see. What do I have planned for tomorrow morning? Do I even have anything planned for tomorrow morning? Maybe we play Tooth and Tail tomorrow morning. Tooth and Tail might be tomorrow morning stream, because I actually I can't think of any projects that we have going on that I need to update you guys on. So, aside from the obvious ones that I already mentioned, and the Stream Deck, it may not be. Yeah, we'll see what happens with Stream Deck. So yeah, maybe it is Tooth and Tail tomorrow morning. Otherwise, let's see, anything else I'm missing? I don't think I'm missing. Oh, I have a project that I'm working on the side that I haven't told you guys about. If I have that completely finished off, I'll at least show it to you. It's not something. It's one of those things I didn't do it online on stream because I'm doing it with materials that aren't readily available that I'm getting from work. So it's one of those things, it's not as useful for you guys, which is why I didn't design it on stream. However, once it is done and put together, and I have it partially put together, I just got to finish out the frame on it. Once that is done, I will show you guys that guy on stream, just so that you can see what I ended up with. Otherwise, I think that is my 20-minute mark for my outro. Again, outros are always at least 20 minutes of rambling. So, I can now sign off. As always, guys, thank you guys for watching and hanging out. Thank you for any comments you leave. And I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world. And I will catch you next time.